Hello, welcome to this video. So this video will be about a conventional question in paper 1 of DSE about um, application of trigonometry in three-dimensional space. So we have a triangular paper card, PQR, drawn in figure 2. So PQ lying on the horizontal ground. So PQ is 30. PR is 25 and QPR is 95. So B1, we want to find QR, so which is the opposite side of 95 degree. So this is an SAS triangle, so that's why for A1, so we'll basically use the cosine formula. So QR squared equals to 25 squared plus 30 squared minus 2 times 25 times 30 times our cosine 95 degrees. So QR, so using calculator, so remember to take the square root, of course. So QR, okay, will be 40.6907 So let's remember this is A. My safe answer. So 2 marks already, good. A2. Now we got QR. We want to find angle PQR. Okay, so PQR corresponding to this angle. And then so just now, okay, we got QR as well as 95 degrees. Yeah, okay, I think it's pretty clear. Anyway, so I'll just try to make use of the sine formula. So that's why his sine angle PQR corresponding to 25 equals sine 95 degrees over QR. So PQR are soffits, so that will be 37.7380 and I375 degrees. So this one, okay, we try to save FB. Good. So that will be all about part A. Part A, so that will be just 2D problem. Okay, so part A done. Okay, and then we go to part B. So in the part B, okay, so I try to mark down all the information. So this is A, and then this is B. Good. So in part B, let Q be the midpoint of, let M be the midpoint of QR. So M will be somewhere here. So the angle between PR and the horizontal ground is 70 degrees. So we want to find the angle between PM and the horizontal ground. Okay, so first of all, PR is here. Here we need to have the projection of R on the horizontal ground, and try to link it to Q as well. And then similarly, okay, anyway, so let's label the angles first. So this is 70. If this is right angle, of course, okay, this is projection. So we try to have the names of projection of R, so that would be, let's say, A then. So of course, RA would be perpendicular to PA, of course perpendicular to AQ. RA, okay, will also be perpendicular to any line, okay, on the horizontal ground. So we just try to put that down then. So B, okay. So first of all, we try to denote A, or the projection, the projection of R on the horizontal ground by A. Okay, so and then in that case, we can easily find AR just using right angle trigonometry learned in junior form. So don't forget PR, okay, in part A, PR, okay, is 25. So that's why AR, okay, will be 25 sine 70. So using the calculator, so that will be 23.49 231552. And then similarly, we can find AP, but is it necessary? Well, anyway, so and then after that, we can also find QM. So QM, okay, will be QR divided by 2. So don't forget this answer, we try to let it be C then. So we have to find QM. So that will be QR divided by 2. So just alpha A divided by 2, so which is 20.34535336. That will be D. Okay, good. Alright, so and then after that, okay, so we can find out PM. Okay, so we can try to have this PM. Okay, so PM and QM. Since okay, we got angle, we got this angle, and then we have PQ, and then now we have QM, so that we can find PM. So that's why once again we can make use of the cosine formula. Cosine of angle PQR, which is found in A2. Good. So PM, QM is D. So that will be 18.669. Okay, and then that will be X. Good. And then now what we want to find the required angle between, the angle between the line segment PM and the horizontal ground. So that's why we need to have, okay, this one, 3. Okay, so we need to have another projection. And then this. Okay, so let's denote the projection of M on the horizontal ground. So this is B then, because we have A, so that's why this is B. Of course, this is right angle. okay, and then we want this angle. Okay, so we try to have, okay, just some more steps. Denote, projection of M on the ground by B. So we have a technical mark here. So the required angle would be angle MPB. And if for this triangle, we have just now find, do we have BM? Oh, not yet. We have just sub PM, right? So we need to find BM. So how to find BM? So BM, okay, so because this is midpoints, and then of course, okay, PA is parallel to BM. So that's why here, okay, we can try to make use of the intercept theorem, okay, to have QM equals to AB, and then we then try to make use of the two midpoints. B is the midpoint of AQ, while M is the midpoint of BQ. So and then we can use the midpoint theorem. So or maybe just using the similar triangle, the ratio stuff. Okay, so BM. Okay, so BM just equals to AR divided by 2. So AR already find in the previous steps, which is C, right? So C divided by 2. 11.74 knots. And then we try save to be Y then. Right, so and then we got BM as well. Okay, so that's why, okay, finally we just try to have a sine angle MPB equals to BM over PM. So and then angle MPB, so that would be just Y over X as our bits. So that will be 38.98730493 degree. And then this is less than 40 degrees. The craftsman suggested that or claims that the required angle will exceed, okay, but not less than 40 degrees, right? Exceeds 40 degrees. So that's why, okay, in this case, the claim is incorrect. And then this part is done. Okay, so and then this is the end of this video. Thank you for watching.